Hi, everyone. Today's lesson is a quiz review, which covers sections 8.1 to 8.3. So let's get started. The first question that is also in your packet, by the way. A right triangle has one leg with length of 7 and another leg of 8. So we're assuming this is a right triangle, so I'm going to draw in the little right angle here. One length is 7 and the other length is 8. What is the length of the hypotenuse? So you're going to use Pythagorean theorem, which says leg squared plus leg squared equals the hypotenuse squared. So we're going to say 7 squared plus 8 squared is equal to x squared. So we have 49 plus 64 is equal to x squared. We have x squared is equal to 49 plus 64, which is 113. We're going to square root both sides. And in square rooting both sides, we're going to get x is equal to the square root of 113 and equals. Keep in mind that we talked about this in the introduction to right triangles video prior to this lesson, but remember that when you're taking the square root of a squared value, the value inside is what comes out. The reason for that, just a side note, is that what you have is x squared here inside this root, okay? So that root, inside a root is a little 2 here because that's a square root, and a 1 here. So if I had had x, just x, not x squared, just x, this value would be x to the 1/2 power. So a root, just a root, is actually what we call a 1/2 power. So when you take the square root of x squared, so what you're really doing is you're taking x squared and you're saying that's to the 1/2 power, whereas the 2's are going to cancel out and you're going to get just x. So that's why x ends up being a solution by itself. So number 2 says, find the length of the missing leg. So again, you're going to go x squared, or excuse me, side squared plus side squared is equal to the hypotenuse squared. So 5 squared plus x squared is equal to 13 squared. You have 25 plus x squared is equal to 169. You're going to subtract 25 from both sides. You get x squared is equal to 144. Again, we're going to square root both sides, and you're going to get x equals 12. So a couple of things that I want to talk to you about. Number 1, how many of you recognize this as being a Pythagorean triplet? Okay, so remember what the triplets are. There's 3, 4, 5. There's 5, 12, 13. Okay, there's 7, 24, 25, and 8, 15, 17. And so what these are we call them Pythagorean triplets because what they are numbers that are trio of numbers, and basically they're very common numbers that you see often in a right triangle. Okay, so you should be able to just recognize, oh, here's 5, here's 13, this must be equal to 12. And all of this work that we just did, you don't have to do. Just again, and then the last thing I wanted to talk to you about was the square root of 144. Remember, why did you lose the root? Where did it go? And just to keep in mind, a root is a 1/2 power. So like if I had the square root of x, that's going to be x to the 1/2 power. There's a little 1 here and a little 2 here that we know is there, but we don't see. And when I have another way of writing 144 is actually 12 squared. So when I say the square root of 144, I'm saying the square root of 12 squared, which I'm actually saying 12 squared to the parenthesis 1/2 power, and the 2's are going to cancel and you just get 12. And so basically that's why the root just disappeared like that. Okay. This is the geometric mean between 7 and 12. So what we're asking for this is, what is this value here? So you have 7 length, leg is to height as height is to leg. And so actually those could be flipped around, but it doesn't really matter. We're going to go 7 is to x as x, 7 is to x as x is to 12. We're going to cross multiply. We get x squared is equal to 7 times 12, which is 84. So we have x squared is equal to 84. And let's see, you want to break down 84 because what I have is x equals the square root of 84. Remember, we're going to take the square root of both sides so that we get x by itself. But the square root of 84 is, we can rewrite that as, I know 4 goes in there, 4 times 2, 1, 21. So this is really the square root of 4 times the square root of 21. Well, the square root of 4 is 2. So x is going to equal 2 root 21. And so that is my geometric mean. Okay. Number 4 says the length of a rectangle is 6 centimeters. So we have 6 centimeters is the length. And then we know the width is 3 centimeters. Find the length of the diagonal. Remember, in a rectangle, the diagonals are congruent. So that's the same length. So we have 3, 6 in this value here. We don't know what that is, so I'm just going to call it x. So we're going to go 3 squared plus 6 squared is equal to x squared. We have 9 plus 36 is equal to x squared. We have 9 plus 36. 9 plus 36 is what, 45? So we have square root of 45. X equals x squared. We're going to take square root of both sides. We get x is equal to root 45 is going to break down to 9, root 9 times root 5. And the square root of 9 is 3. So we have 3 root 5, which is equal to x. So my diagonal's length right here is equal to 3 root 5. Now, these are exact values. We're not approximating, so I don't want you to guess what this value is. I just want you to leave it as an exact value, meaning no decimals, no approximation. Okay, so we have a right triangle. The measures of the legs are 12, x minus 5, and and the hypotenuse is x plus 3. So here's my hypotenuse off of my right angle. Here we go, x plus 3. We know one side is 12. We know the other side is x minus 5. So your job is to find the value of x. So we're going to use Pythagorean theorem because it is a right triangle. We're going to say 12 squared plus, so we're going to say leg squared plus leg squared. So plus x minus 5 quantity squared is equal to x plus 3 quantity squared. We get 12 squared, which is 144, plus, now this is x minus 5 quantity squared, x minus 5 times x minus 5 is equal to, this is quantity squared. So keep in mind, it's the whole quantity squared. So it's x plus 3 times x plus 3. X plus 3 times x plus 3. Let me fix that. Okay, so what we're going to do is we're going to multiply this out. We're going to get 144 plus, now let's FOIL. Okay, so x times x, we have x squared, minus 5x, which makes minus 10x, and negative 5 times negative 5 is positive 25, and that equals, I'm going to FOIL again on the right side, x times x, which is x squared, x times 3 is 3x plus 3x, so that's going to make plus 6x, and positive 3 times positive 3 is 9. So what's going to happen here is, it looks like if I were to subtract x squared from both sides, my x squareds are going to cancel, okay? So what I have now is 144 minus 10x plus 25. So 144 plus 25 is actually 169 minus 10x equals 6x plus 9. So I'm going to add 10x to both sides. So in adding 10x to both sides, I'm going to get 16x on the left, on the right. And I'm also going to subtract 9 from both sides to get rid of that 9 that's on the right. So now I have these canceled, those canceled. 169 minus 9 is 160. I'm going to divide both sides by 16, and I get x is equal to 10. Okay, so that's my value of x. It's possible that not only am I going to ask you for the length of 10 or the length of x, but it's possible that you also might need to know what the lengths of the sides of the triangle are. So if that was the case, you know that's 12. If x was 10, this would be 10 plus 3, so that'd be 13. And here, oh look, 10 minus 5, which is 5. And look again, this is a 5, 12, 13. What a coincidence. So here we go. The perimeter of the square is 20 centimeters. Find the length of the diagonal. So again, this is a square. So it told me it's a square. So there's my right angle. Here's my diagonal. The perimeter, so we don't know that. The perimeter is 20. So, if it's a square, you have to remember that all the sides are equal. So if I were to take 20 and divide that by 4 sides, I'm going to get 5 sides for each, the length of 5 for each side. So we're going to use Pythagorean theorem because it is a right triangle. So we're going to say 5 squared plus 5 squared is equal to x squared. We have 25 plus 25 is equal to x squared. And we have, that's going to be 50 is equal to x squared. We're going to square root both sides. Again, we're going to lose the root by square rooting that. So we have x equals the square root of 50. And I'm going to break square root of 50 down into root 25 times root 2. And so that's going to equal 5 root 2. And so there's my value of my diagonal. Okay, cool. Now this one can be a really tricky problem, okay? Find the length of a diagonal of a rectangular box. So there's the diagonal I want to find. Ultimately, that's it right there. So I'm going to call that x. Okay, now my rectangular box has sides 6, 10, and 8. Okay. I need to be able to figure out how to find this. Now, keep in mind a couple of things. This is a parallelogram. It's a box. And basically, so you know that all the angles are right. What I need to do is to create a right angle, I need to find a triangle. See, so if I can do this, right, draw this down like this, and I were to come through and create this, see that right angle? If I did that, I would be able to go 8 squared plus whatever this length squared is here is equal to that squared. So I would be able to find the length of my diagonal. But it looks like I actually have 2 separate problems, right? I've got this problem here, which I'm going to redraw just kind of like on the side, right? There's this problem here because ultimately that's what I want to find. That's 8. I don't know what this is yet. So what I'm going to do before I do that is I'm actually going to use another right triangle to find that length on the bottom. See that? So I'm going to see this right triangle here. So I'm going to say 6 squared plus 10 squared is equal to, I don't know, let's call this y, y squared. So we have 36 plus 100 is equal to y squared. So y is equal to the square root of 136. Now, don't reduce that because that's what this value is right here, right? That's this value right here, which is the square root of 136. And keep in mind, I am going to find x by using Pythagorean theorem one more time. And that means that I'm going to take the square root of 136 squared plus 8 squared is equal to that diagonal squared, which is ultimately that value in the box that I want. When you square root a square, remember that's just 136 plus 64 is equal to x squared. And it looks like 136 plus 64 is 200 is equal to x squared. I'm going to square root both sides, and that's going to be x equals the square root of 200, which breaks down, of course, to 10 times 2, 100 times 2. So let's say that's 100 times 2, root 2, right? Yeah. And so the square root of 100 is 10. So we have 10 root 2. And so there's my length of the diagonal, which is right here, is 10 root 2. Okay, cool. This one is A is 4. So here's this length 4. X is 2. There's 2. And find C. Okay, so we got to find C. C is the length of this hypotenuse. So this looks like a hypotenuse leg problem. Okay, so we're going to go, let's see here, little triangle. Hypotenuse is to leg. So we're going to go 4 is to 2 as hypotenuse. Now this is the hypotenuse of my big triangle, right? As my hypotenuse, which we're going to call that C, is to the leg of this, see this leg of the, okay, so what you're looking at is the big triangle, right? And you have the hypotenuse, which is C, and then this is the leg. all right? So as to 4. So we're going to cross multiply. 2 times C is equal to 4 times 4, which is 16. I'm going to divide by 2 on both sides, so C is equal to 8. Okay. This one says, now if C is 18, okay, so here's 18, Y is 10, okay, that makes that 8. Find B. Where's B? Here's B. So we want B. So this looks like, okay, so I have choices here. I mean, you definitely have choices. You can do this. 8 is to H as H is to 10. Totally fine. If you did that, you find H. Once you find H, then you're going to use the Pythagorean theorem. Okay, that's an option. We also cannot do that. We also can just do, let me fix this. So C is 18, that's the whole length. Y is 10. Find B. Where's B? Here's B. So we're going to do this. We're going to use this right side, okay? And we're going to use hypotenuse leg. So I like this formula. Hypotenuse is to leg as hypotenuse is to leg. So I'm talking about the large triangle, and I'm talking about the smaller triangle. So the large triangle's hypotenuse is 18, is to its leg, which is, I don't know, B. And now I'm talking about the small triangle. Now this is my small triangle right here, okay? And then you've got the hypotenuse, which is B, is to leg, 10, longer leg. So we've got B squared is equal to 10 times 18. I'm going to square root both sides, and I get 10 times 18. So I get B is equal to, I'm going to split this up. 10 is 2 times 5. 18 is 9 times 2. Let's see what we can pull out. We know the square root of 9 is 3, so that's coming out. We've got 2 times 2 is 4, root 4, square root of 4 is 2, 2's coming out. And we have a 5 left inside, so B is equal to 6 root 5. Okay. This one says if X is 2, so here we go, this is 2, Y is 5, find H. Oh, well that one, that's my favorite one. Base is to height as height is to base. So we're going to go 2 is to H as H is to 5. So we have H squared equals 2 times 5, which is 10. We're going to square root both sides, and we get H is equal to the square root of 10. Now again, that's an exact value. I don't want you to try to reduce that. Well, first of all, it can't reduce, but you can most of the time approximate, what is this about? If you were to be asked like on a test, what is this approximately? What perfect squares do you know? You know the square root of 9, which is 3. You know 9, 10, let's see here, 3, 4. Square root of 4, or square root of 16 is 4. And you know that the square root of 10 is in between here, right? Well, that means it's in between 3 and 4. So is it closer to this? Yeah, way closer. So this would be like 3.1 or 3.2, right? As opposed to 3.5 being right in the middle, and then 3.9 being like square root of 15 or something like that. Okay. H is 5. B is 10. Here's 10. Find Y. Oh, well, this is just a Pythagorean theorem. We've got 5 squared plus Y squared is equal to hypotenuse squared, right? Leg squared plus leg squared equals hypotenuse squared. So we have 25 plus Y squared is equal to 100. Subtract 25, I get Y squared is equal to 75. I'm going to square root both sides. The Y is going to unsquare root itself and become Y. Square root of 75 is actually square root of 25 times the square root of 3. Well, the square root of 25 is 5. So we have Y is equal to 5 root 3. And so that's what Y is. Number 12 says the perimeter of an equilateral triangle is 15. So by it being equilateral, that means all sides are congruent. So all 3 of these sides are the same. So the perimeter is 15. So that means all of these sides are 5. Find the measure of the altitude. Now the altitude is going to come straight down. Okay, so that's going to come straight down like this. And it's going to be perpendicular. And we know this is now what, 2.5? So That's not a nice number. What do we want to know? X, the altitude. So we're going to say x squared plus 2.5. 2 1/2 is the same thing as saying 5/2. So it's x squared plus 5/2 squared is equal to my hypotenuse, 5 squared, okay? And so what we have is x squared is equal to 25 minus this. I'm moving this over to the other side. So minus 25 over 4, right? Because 5 over 2 roots or squared is just 5 over 2 times 5 over 2, which is 25 over 4. And so that's where that came from. Problem with this actually is that my denominators need to be the same before I can add them. So I need to multiply this by 4 over 4 because that's 1. And I'm not changing the problem by multiplying by 1. So what I have is x squared equals 25 times 4, which is what? 100 minus 25 all over 4. Well, x squared, I'm continuing down here. 100 minus 25 is 75 over 4. So now, finally, that's a 4, by the way. Now we're going to square root both sides, okay? So by square rooting both sides, keep in mind the whole thing gets squared. I have x is equal to, now, a root that covers both top and bottom, numerator and denominator, can be split up as to root 75 over root 4, okay? Well, the square root of 4 is 2, all right? So we know that's 2. But this, root 75, is going to be broken up into root 25 times root 3. So what that is going to equal is square root of 25 is 5. So I have 5 root 3 all over 2. Yay. So there's my answer. Okay, so I think lastly, this is on your review. Your job is to figure out if this is right, or excuse me, acute, right, obtuse, or not even a triangle. Because remember, the sum of two sides of a triangle have to be greater than the third side. So that's really important that you remember that. So meaning, let's just double check all of these real quick. 1 plus 2 is 3. 3 is greater than 2. Okay, that works. 4 is greater than 1. 1 plus 2 is 3. 3 is greater than 2. Okay. 9 plus 12, 21 greater than 13. These are greater. 8 plus 8 is what? 16. 16 is greater than 9. That's greater than 8. 3 plus 11 is 14. Is 14 greater than 15? This one is not a triangle because the sum of two sides, meaning 3 plus 11, has to be greater than 15 for a triangle to exist. Meaning it doesn't exist because it kind of looks something like this, where that would be 11, and then you'd have this is 3. Meaning, you know, you've got a side of 11, a side of 15, and then you've got this one side that like doesn't reach anything. So that triangle does not exist. So you'd say none. Okay. For this one right here, classify as acute. So let's just reiterate. Let me just remind you of what these are. If you have c squared is equal to a squared plus b squared, it's a right triangle, okay? If c squared is greater than the sum of these two other sides, a squared plus b squared, then that's an obtuse triangle, okay? If you have c squared is less than a squared plus b squared, the sum of the two other sides, if it's less than, well, that's going to be an acute triangle. So let's figure out what these are. You always start off with c squared, okay, because it just makes it easier to figure out. So in c is always the largest side. So here's my c, largest side. Here's my c, here's my c. So I'm going to go c squared. So I'm going to go 2 squared is what? To 1 squared plus 2 squared, okay? This is my c again. Oh, so let me finish the problem. So we've got 4 is what? To 1 plus 4. Well, that's 5. So 4 is less than 5. So if it's less than, it's an acute triangle, okay? Alrighty. Then I have the next sides. I've got 13 squared, that's my c, is what? To 9 squared plus 12 squared. So we've got 169 is what? To 81 plus 144. 144 plus 81 is a lot bigger. So again, this one right here is less than, 169 is less than, so that's acute also. Okay, let me try to spell this better. A-C-U-T-E. Okay, now this one, this one says, this is my C, so 9 squared is what to 8 squared plus 8 squared? So we've got 81 is what to 64 plus 64? Boy, that looks like it's less than again. Okay, so this is another acute triangle. This one is not a triangle. And let's check this one out. Ooh, this looks like a triplet. Anyway, let's try this. So we've got C squared. So 20 squared is what to 12 squared plus 16 squared? So we have 400 is what to 144 plus, this is what, 256? 256, 144, 144, 256. That looks like 400 to me. So these are equal. So therefore, this is a right triangle. Okay. Unfortunately, I didn't see an obtuse triangle. So let me make one up. Let's see if I can make one up. Let's see. We want this one to be bigger. So let's say 13. Another side might be 4 and 10. Is that going to work? I think that's going to work. That would mean you would have 169, 13 squared, is what to 10 squared plus 4 squared. So that's 16. So 100 plus 16 is 116. And that's 169 is greater. 169 is greater than 116. So this would mean this is an obtuse triangle. Okay, cool. Well, that's it. I hope that helped you with the test review or the quiz review. And see you next time. Thanks. Thanks for watching.